Hello guys, welcome back to my YouTube channel. It's me, Afraz, the Knowledge Man, back with another video. In today's video, we're going to be discussing equations reducible to quadratic form. Let's get right into it. As we now know how to solve quadratic equations, we're going to be using our knowledge of quadratic equations to solve equations that aren't really quadratic as such, but they can be reduced to quadratic form. This topic is split into a number of cases, starting off with case 1. In case 1, we have equations of the type ax to the 4th power plus bx squared plus c is equal to 0. Only quartic equations of this type. We can't have ax to the 4th plus bx cubed plus c is equal to 0, or ax to the 4th plus bx cubed plus, cubed plus cx squared plus dx is equal to 0, or ax to the 4th plus just bx cubed is equal to 0, or say ax to the 4th plus cx squared plus dx plus e plus bx cubed is equal to 0. Nope, none of these are going to work. Only equations of the type ax to the 4th plus bx squared plus c. Only equations of this type. So, now say we do have an equation of the type ax to the 4th plus bx squared plus c is equal to 0. What are we going to do now? How are we going to solve this? Well, we're going to let variable x equal another variable y. So we're going to let x squared equal y, and then if we square on both sides of x squared is equal to y, we get x to the 4th is equal to y squared. And now, replacing the values of the variables, we get a new equation, ay squared plus by plus c is equal to 0. Now we have a quadratic equation, and we can use any method that we see fit to solve this equation, and then we get the roots. After getting the roots, we put the roots into the relationship right up here. This one. We just put it into this relationship and find the values of x. Let's see an example. Let's say we have 4x to the 4th minus 13x squared plus 9 is equal to 0. This is in the form ax to the 4th plus bx squared plus c. So we're going to let x squared equal y. So if squared x to the 4th is equal to y squared. And now replace. And by replacing, we get 4y squared minus 13y plus 9 is equal to 0. Let's see if we can factorize this equation. AC is equal to 4 into 9, which is equal to 36. And the factors are 1 into 36, and 2 into 18, and 3 12s, 4 9s, and finally 6 and 6. So let's look at these signs of the product of A and C, which is positive, and the sign of B, which is negative. So this tells us that both of the factors in the pair must be negative, so that their sum is negative 13 and their product is positive 36. So we can have, the scenarios are negative y minus 36y, negative 2y minus 18y, minus 3y minus 12y, negative 4y minus 9y, and negative 6y minus 6y. So negative 37y, negative 20y, negative 15y, negative 13y, and negative 12y. And since b is negative 13y and the result must be negative 13y, or else we can't factorize, we're going to be using the fifth one. Okay, so let's use the fifth one. We get 4y squared minus 4y minus 9y minus 9 plus 9 is equal to 0. Now from here, let's take 4y common. We get 4y into y minus 1. And here, let's take negative 9 common. We get minus 9 into y minus 1 is equal to 0. And now out of the left-hand side, let's take y minus 1 common. We get y minus 1 into 4y minus 9 is equal to 0. Now we can see that the product of y minus 1 and 4y minus 9, is equal to 0. So that means that one of these must be 0. Either y minus 1 is 0 or 4y minus 9 is equal to 0, so it multiplies into the other. But we don't know which one is equal to 0. So we're going to write either y minus 1 is equal to 0 or 4y minus 9 is equal to 0. So y is equal to 1 and y is equal to 4y is equal to 9. So y is equal to 9 over 4. And so y is equal to 1 and 9 over 4. But it doesn't end right here. When we started this question, we started to find the values of x, and we just found the values of y. Since we let x squared equal y, then we can also write this as x is equal to positive and negative under root of y. The square root, I mean. Now we're going to put each of y's values here, right here. And we're going to find the values of x. So for y is equal to 1, x is equal to positive and negative under root of 1. And so x is equal to positive and negative under root of 1 squared. And the square and the square root cut out. And we get x is equal to positive and negative 1. This is one value. Two values. And for y is equal to 9 over 4, x is equal to positive and negative square root of 9 over 4. So x is equal to positive and negative under root of 3 over 2 squared, square root and square cut out, and we get x is equal to positive and negative 3 over 2. So the solution set for x is equal to positive and negative 1 and positive and negative 3 over 2. And since we started with a quartic equation, and quartic equations have 4 values, we just got 4 values. We've got x is equal to 1, negative 1, 3 over 2, and negative 3 over 2 for your information. And that's it for case number 1. Let's move over to case number 2. Case number 2 involves polynomials. And I'm pretty sure you're familiar with polynomials already, but just in case there's someone who isn't, let's just review it really quick. A polynomial is an algebraic expression that is made up of variables, constants, and exponents that are combined with mathematical operations like addition, subtraction, etc., etc. But note that if we have division, we can't really divide by a variable, or else it's no longer a polynomial. Polynomials can actually consist of just a constant. They're classified as monomial, binomial, trinomial, etc. In monomial, mono stands for or means 1. So a monomial is a polynomial with only one term. So it can be a constant such as 3, or an expression such as 5xy, or just 5x, just 3y. And in binomial, bi stands for 2. So a binomial is a polynomial with 2 terms, such as 2x plus 3, or 2x plus 1, 5x minus 9, any expression which has 2 terms. And the trinomial stands for 3. So a trinomial has 3 terms, 3x plus 2y plus 1, or 3x squared minus 9y squared plus x, etc., etc. And a polynomial, poly in polynomial stands for multiple or many. So a polynomial is an expression which consists of many terms or multiple terms. And in the equations that we're going to be talking about in case 2, they're of the form a into p of x, where p of x means polynomial of x, plus b divided by that same polynomial of x is equal to c. So all we're going to do here is let p of x equal y. So we get a into y plus b over y is equal to c. C is equal to c. So a into y is ay plus b over y is equal to c. Now let's multiply all terms by y. We get y into ay plus y into b over y is equal to c into y. So this y and this y cut out, and now we don't have denominators, and we get ay squared plus b is equal to cy. Sending cy to the other side, to the left hand side, we get ay squared minus cy plus b is equal to 0. Now we have a quadratic equation. We can solve the equation using any method we like, and then the values we get, we're going to put that in the relationship polynomial of x is equal to y, and then we're going to get the values of x. So let's take an example. Say 2x squared plus 1 plus 3 over 2x squared plus 1 is equal to 4. So we're going to let 2x squared plus 1, which is a binomial, equal y. We get y plus 3 over y is equal to 4. Multiplying all these terms by y into y plus y into 3 over y is equal to 4 into y, and y cross out, and we get y squared plus 3 is equal to 4y. Now sending 4y to the left hand side, we get y squared minus 4y plus 3 equals 0. And let's see if this is factorizable. AC is equal to 1 into 3, which is equal to 3, and the factors are 1 into 3. And the signs tell us, since AC is positive and B is negative, this means that both of the factors in the pair must be negative, so that their sum is negative and their product is positive. So we get negative y minus 3y is the only case or only way we can factorize it, and we get negative 4y, so it will work. So let's use it. We get y squared minus y minus 3y plus 3 is equal to 0. Now, right over here, we're going to be taking y common, so we get y into y minus 1. And right here, we're going to take negative 3 common, so we get minus 3 into y minus 1 is equal to 0. And now out of this equation, we're going to take y minus 1 common, so y minus 1 into y minus 3 is equal to 0. So now we can see that their product, y minus 1 into y minus 3, the product is equal to 0. And once again, we don't know which one is equal to 0, because one of them needs to be 0 since it multiplies into the other and we get 0. So we're going to say either y minus 1 is equal to 0 or y minus 3 is equal to 0. So y is equal to 1 or y is equal to 3. So solution set for y is equal to 1 and 3. And now that we have the values of y, since we let 2x squared plus 1 equal y, we're going to be putting each of y's values right here in this equation. So for y is equal to 1, 2x squared plus 1 is equal to 1, so 2x squared is equal to 1 minus 1, and so 2x squared is equal to 0. And x squared is equal to 0. If we send 2 to the other side, it divides, and yeah, 0 divided by 2 is 0. And now we can take the under root, but it doesn't make a difference, so x is equal to 0. That's one value. And the second value of y is, for y is equal to, what was the second value? Yes. For y is equal to 3, 2x squared plus 1 is equal to 3. So 2x squared is equal to 3 minus 1, and 2x squared is equal to 2. Dividing both sides by 2, we get 1. So x squared is equal to 1, taking the under root on both sides, positive and negative. X is equal to positive and negative under root of 1 squared, and we get x is equal to positive and negative 1. So the solution set for x is equal to 0 and positive and negative 1. Solution set. And just like sometimes for quadratic equations, we get one value instead of 2. In quartic equations, we just saw, or we're seeing right now, that instead of 4 values, we got 3. Now let's move on to case 3. Which is about reciprocal equations. Now, what are these reciprocal equations? Well, reciprocal equations are the equations in which replacing a variable by its reciprocal doesn't change the equation. So, if we replace x by 1 over x, we're going to be left with the same equation. And not all equations are, of course, reciprocal. And not all reciprocal equations can be solved by the method we're going to be using in this video, or right now. So, let's look at the type of reciprocal equations we can apply the method on. Reciprocal equations of the type ax to the fourth plus bx cubed plus cx squared plus bx plus a is equal to 0. Now pay attention here. Right here, this a and this a, this isn't just some random coincidence that I wrote it like that. It must be like that. The x to the fourth term, the coefficient of x to the fourth, must be equal to the constant. And the cube term, the coefficient of the cube term and of the linear term, the x to the first power term, must be equal. If they're not, then we can't use this equation. This method. If we have ax to the fourth plus cx cubed plus dx squared plus bx plus e is equal to 0, this is not going to work because these two aren't equal and neither are these two. It doesn't have to be c, it doesn't have to be b, because they're going to be numbers and they have to be equal. And this, it's still like fine, but it doesn't even matter until these aren't equal. All of these, they must be equal. A and the constant, the x to the fourth term, this coefficient and the constant must be equal, and the cubed term's coefficient and the linear term's coefficient must be equal. And the other type is a into x squared plus 1 over x squared plus b into x plus 1 over x plus c is equal to 0. And to know if you have a reciprocal equation, like I said before, they don't change if you replace the variable by its reciprocal. So just replace x by 1 over x. So let's do that in this equation. We get a into 1 over x squared, we replaced x by 1 over x, plus 1 over x is equal to 1 over x, so 1 over 1 over x, and this is being squared down here, plus b into x is 1 over x and 1 over 1 over x, plus c is equal to 0. So a into 1 over x squared plus 1, we can also write this right here, this term as 1 divided by 1 over x squared. And if you want to turn any division into multiplication, you have to flip over the fraction. So it's 1 over x, it's going to turn into x over 1, which is x. So this is going to turn into 1 multiplied by x over 1, you could say, squared. Not that it matters, but we're just going to write it for the step. Plus b into 1 over x plus 1 into x over 1. We did the same, we're doing the same thing here that we did right here, is equal to 0. A into 1 over x squared plus 1 into x squared is equal to x squared, plus b into 1 over x plus 1 into x is equal to 0. So we have the same exact equation as we did back up here. We have the same exact equation. you could like rearrange this and you'd get exactly in the same order, but the order doesn't matter as long as it's the same, because they're equal. Anyway, yeah. So we just proved that was a reciprocal equation. This is a reciprocal equation. And what about ax to the fourth plus bx cubed plus cx squared plus bx plus a is equal to 0? Well, here we're going to divide all terms by x squared. So ax to the fourth divided by x squared plus bx cubed divided by x squared plus cx squared divided by x squared plus bx divided by x squared plus a divided by x squared is equal to 0. So x squared and x to the fourth cut out, we get x squared. X cubed and x squared cut out, and we get x. X squared and x squared cut out, we get 1. X and x squared cut out, we get 1 over x, you could say, or x in the denominator. And we can't simplify here. And we could also write divide by x squared here, but it doesn't make a difference. It seriously doesn't. Because anything divided by, 0 divided by anything is 0. So we get ax squared plus bx plus c plus b divided by x plus a over x squared is equal to 0. Now let's rearrange. Ax squared plus a divided by x squared plus bx plus b over x plus c is equal to 0. Now right here, let's take a common. We get a into x squared plus 1 over x squared. And right here, let's take, right here, let's take b common. We get plus b into x plus 1 over x plus c is equal to 0. So now we have the same equation we had back up here. It's pretty much the same, just we have a constant, and the constant doesn't really make a difference. Yeah, it doesn't. That doesn't make it not reciprocal, because the whole thing is just about these terms. The x 1 over x squared plus x and x plus 1 over x. These terms. That's all that matters. And now what are we going to do? How are we going to solve these? Well, we're going to simply let x plus 1 over x equal y. So now if we square on both sides, we get x plus 1 over x squared is equal to y squared. And opening up the square, we get x squared plus 1 over x squared plus 2 into x into 1 over x is equal to y squared. So we get x squared plus 1 over x squared plus 2 is equal to y squared. So we get x squared plus 1 over x squared is equal to y squared minus 2. And now replacing, we had a into x squared plus 1 over x squared plus b into x plus 1 over x plus c is equal to 0. So a into x squared plus 1 over x squared is y squared minus 2, as we just figured out, plus b into x plus 1 over x is x y plus c is equal to 0. So we get ay squared minus 2a plus by plus c is equal to 0, and ay squared plus by plus c minus 2a is equal to 0. So pretty much that means, since the max term of the variable right now is 2, we have a quadratic equation which we know how to solve. We can use any method that we like, and we'll get the values, the roots, and then we're going to put them in the equality, or the relationship, x plus 1 over x is equal to y. And then we're going to find the values of x. So let's take an example. So x squared plus 1 over x squared minus 11 into x plus 1 over x plus 12 is equal to 0. Now let's let x plus 1 over x equal y. So if squared, we know that we get x squared plus 1 over x squared equals y squared minus 2, as we just proved above. So replacing, we're going to get y squared minus 2 minus 11 into y plus 12 is equal to 0. So we get y squared minus 11y negative 2 plus 12 is positive 10 is equal to 0. So now let's factorize, or let's see if this can even be factorized. AC is equal to 1 into 10, which is equal to 10, and the factors are 1 into 10 and 2 into 5. And now let's look at the signs. We have a positive product of A and C and a negative sign with B. This indicates that both of the numbers, or should I say factors in the pair, must be negative so that their sum is negative and the product is positive. So either negative y minus 10y or negative 2y minus 5y. So negative 11y and negative 7y. And since we can't use negative 7y and we can use negative 11y, we can factorize this equation. Y squared minus y minus 10y plus 10 is equal to 0. Now right here, let's take y common. We get y into y minus 1. And right here, let's take negative 10 common. We get negative 10 into y minus 1 is equal to 0. Now out of this equation, let's take y minus 1 common. We get y minus 1 into y minus 10 is equal to 0. So now we can see that as their product, as y minus 1 into y minus 10 is equal to 0, one of them has to be 0 since it's multiplying with the other one and the product is 0. But we don't know which one. So we're going to say either y minus 1 is equal to 0 or y minus 10 is equal to 0. So y is equal to 1 and y is equal to 10. So y is equal to 1 and 10. Solution set. Now we have values of y, and we're going to put them in the equality x plus, since x plus 1 over x is equal to 1, we're going to put the is equal to y. We're going to put each of y's values into this relationship, and we're going to find values of x. So for y is equal to 1, x plus 1 over x is equal to 1. Multiplying all terms by x to get rid of this denominator right here, we get x into x plus 1 over x into x is equal to 1 into x. X and x cross out. And here x into x is x squared plus 1 is equal to 1 into x is x. Sending x to the other side, we get x squared minus x plus 1 is equal to 0. Here a is equal to 1, b is equal to negative 1, and c is equal to 1. And the quadratic formula is x is equal to negative b plus minus under root of b squared minus 4ac divided by 2a. X is equal to negative into negative 1, we're putting in the values, plus minus under root of negative 1 squared minus 4 into 1, as a and c are 1, divided by 2 into a, which is 1. And so x is equal to negative 1 into negative 1, you can call this 1, it doesn't really make a difference. Negative 1 into negative 1 is positive 1, plus minus under root of 1 squared is 1, and negative 4 into 1 is negative 4, and then multiplied into 1 again, it's negative 4. Oops. Divided by 2. X is equal to 1 plus minus under root of negative 3 divided by 2. And so, yeah, we can also write this as x is equal to plus minus under root of 3 iota divided by 2. And you guys probably know that iota is equal to negative 1 under root of negative 1. And yeah, that's why we wrote it like this. And for x is equal to, y is equal to 10, x plus 1 over x is equal to 10. And multiplying all terms by x, we get x into x plus 1 over x into x is equal to 10 into x. X and x cut out. And we get x squared plus 1 is equal to 10x. Sending 10x to the other side, we get x squared minus 10x plus 1 is equal to 0. So a is equal to 0, b is equal to negative 10, and c is equal to 1. And our formula is x is equal to negative b plus minus under root of b squared minus 4ac divided by 2a. So x is equal to negative into negative 10 plus minus under root of negative 10 squared minus 4 into a is 1 and c is 1 divided by 2 into a is 1. So x is equal to negative into negative 10 is positive 10 plus minus under root of negative 10 squared is 100, and negative 4 into 1 is negative 4, and again into 1 it's still negative 4 divided by 2. So x is equal to 10 plus minus under root of 96 divided by 2, and we can simplify a bit more. X is equal to 10 plus minus under root of 96's factors are 2 into 2 into 2 into 2 into 2 into 3. Yep. Divided by 2. So we get x is equal to 10 plus minus under root of, this is a pair and this is a pair, so under root of 2 squared into 2 squared into 2 into 3, which is 6, divided by 2. So this is a square and this is a square, so they're going to come out of the under root now. So we're going to get x is equal to 10 plus minus 2 into 2 into under root of 6 divided by 2. Let's take 2 common in these terms. We get x is equal to 2 into 5 plus minus 2 under root of 6 divided by 2. And this 2 and this 2 cut out. And we get x is equal to 5 plus minus 2 under root of 6. So the values of x are x is equal to 1 plus minus 3 under root 3 iota divided by 2, and x is equal to 5 plus minus 2 under root of 6. Solution set, solution set. Oops. There you go. That's case number 3. Now for case number 4, which is my favorite. Case number 4 is the case where we have equations with the variable in the exponent form. So they look like a to the power 2x plus a to the power x plus b is equal to 0. All we're going to do is let a to the power x equal y, and then if we square on both sides, we get a to the power of 2x equals y squared. So now if we replace, or should I say when we replace, we get y squared plus y plus b is equal to 0. So we have a quadratic equation, and we know how to deal with these equations. Use any method you see fit, get the roots, then put them into this relationship. Let's take an example. 4 into 2x plus 1 minus 9 into 2x plus 1 is equal to 0. Let's expand a bit, or should I say rearrange a bit. 4 into 2, this is 2x by the way guys, into 2 to the power 2x into 2 to the power 1 minus 9 into 2 to the power x plus 1 is equal to 0. Let's let 2 to the power x equal y, then 2 to the power of 2x will equal y squared. So we get 4 into y squared after replacing into 2 minus 9 into y plus 1 is equal to 0. And we get 4y squared into 2 minus 9y plus 1 is equal to 0. And so we get 8y squared minus 9y plus 1 is equal to 0. Now checking if this is factorizable, AC is equal to 1 into 8, which is equal to 8, positive 8. The factors are 1 into 8 and 2 into 4. And looking at the signs, AC is positive and B is negative, which indicates that both of the factors in the pair must be negative so that their product is positive and their sum is negative. So negative y minus 8y or negative 2y minus 4y. So negative 9y or negative 6y. We need negative 9y, so we're using the first one. So we get 8y squared minus 8y minus y plus 1 is equal to 0. So right here we're going to take 8y common, 8y into y minus 1. And right here we're going to take negative 1 common. So negative 1 into y minus 1 is equal to 0. So y minus 1 into 8y minus 1 is equal to 0. And their product is equal to 0, so one of them must be 0. But we don't know which one's 0. So we're going to say either y is equal to 1. Sorry. Y minus 1 is equal to 0. Or 8y minus 1 is equal to 0. So y is equal to 1. And 8y is equal to 1. So y is equal to 1 over 8. So the solution set for y is equal to 1 and 1 over 8. And now we have values for y. We're going to put it back in the relationship 2 to the power of x equals y, since it does. So we're going to put each of the values of y here. So 2 for y is equal to 1. 2 to the power of x is equal to 1. And I'm pretty sure you guys know, but if you don't, anything to the power of 0 equals 1. So 2 to the power of 0 is equal to 1. And if you didn't know, now you know. 2 to the power of x is equal to 2 to the power of 0. And there's another principle which states that if the bases are same, the exponents are same. And if you didn't know that one, then now you know. So since 2 is the base and it's equal, then x is equal to 0. And for y is equal to 1 over 8, 2x is equal to 1 over 8. And so 2x is equal to 1 over 2 cubed, because 8 is equal to 2 cubed. So 2 to the power of x is equal to 2 to the power of negative 3, because we sent it up, and so we're reciprocating it. And now, since the bases are equal, x is equal to negative 3. So the solution set for x is equal to 0 and negative 3. And that's case 4, my personal favorite. Now let's move on to case 5. So case 5 is pretty simple. Case 5 is when we have equations of the type x plus a into x plus b into x plus c into x plus d is equal to k, where a plus b is equal to c plus d. So yeah, pretty much that's it. We have to look at just that a plus b equals c plus d. If that's there, then yeah, we can use it. So, but it has to be in this form, that there are 4 terms multiplying. Now, we're going to multiply these 2 terms, and we're going to get a quadratic expression. Same here. And then we're going to let the quadratic expression equal y. Because if we multiply the quadratic expressions, we're going to get a quartic expression. And sending k to the other side, on the left-hand side, we're going to have a quartic equation. And we don't know how to solve those. We only know how to solve a type of those, a certain type. So, let's take an example to understand it better. The example is x minus 1 into x minus 2 into x minus 8 into x plus 5 plus 360 is equal to 0. Okay, so here, certainly, a plus b is negative 3, and c plus d is negative 3. So that worked out. And if it's not, if it was like x minus 1 into x minus 8 into x minus 2 into x plus 5, we still could have just rearranged it. You can't just leave it there and go like, no. Just for your information. But anyway. So x into x is x squared, x into negative 2 is negative 2x, negative 1 into x is negative x, and negative 1 into negative 2 is positive 2. X into x is x squared, x into 5 is positive 5x, negative 8 into x is negative 8x, and negative 8 into 5 is negative 40. Plus 360 is equal to 0. So let's simplify these two and these two. We get x squared minus 3x plus 2 into x squared minus 3x minus 40 plus 360 is equal to 0. So now if we multiply x squared into x squared, we're going to get a quartic equation. So to avoid that, we're going to let x squared minus 3x equal y. And so we get y plus 2 into y minus 40 plus 360 is equal to 0. And now multiplying y into y is y squared, y into negative 40 is negative 40y, 2 into y is 2y, and 2 into negative 40 is negative 80, plus 360 is equal to 0. Simplifying these two and these two, we get y squared minus 38y plus 280 is equal to 0. Now let's check if this is factorizable. AC is equal to 1 into 280, which is equal to 280. And there are a lot of factors, so let's get right into it. 1 into 280, 2 into 140, 4 into 70, 5 into 56, 7 into 40, 7 into 40, not 8, 10 into 28, and let's just stop here because I see the factors. So the product is positive, AC is positive, and B is negative. So yeah, this tells us that both of the factors in the pair must be negative so that their sum is negative, and since they're the same signs, the product is going to be positive. So negative y minus 280y, negative 2y minus 140y, negative 4y minus 70y, negative 5y minus 56y, negative 7y minus 40y, and negative 10y minus 28y. So negative 281y, negative 142y, negative 74y, negative 61y, negative 47y, and negative 38y. Since we need negative 38y, we're going to be using the last one we found, the last factor, pair of factors. So our equation is, for now, it's y squared minus 38y plus 280 is equal to 0. And now y squared minus 10y minus 28y plus 280 is equal to 0. Right over here, let's take y common, y into y minus 10. And right here, let's take negative 28 common, negative 28 into y minus 10 is equal to 0. Now on the left hand side, let's take y minus 10 common, y minus 10 into y minus 28 is equal to 0, 0. And now since y minus 10 into y minus 28 is equal to 0, one of them has to be 0, but we don't know which one. So we're going to say either y minus 10 is equal to 0, or y minus 28 is equal to 0. So y is equal to 10, and y is equal to 28. So y is equal to 10 and 28. So yeah, now we have the solution set for y. So since we said that x squared plus 3x is equal to y, we're going to put each of y's values into this relationship. So for y is equal to 10, x squared plus 3x is equal to 10, and so x squared minus 10 plus 3x is equal to 0. And let's rearrange that. So we get x squared plus 3x minus 10 is equal to 0. Now let a is equal to 1, b is equal to 3, and c is equal to negative 10. Our formula is x is equal to negative b plus minus under root of b squared minus 4ac divided by 2. X is equal to negative into 3 plus minus under root of 3 squared minus 4 into 1 into negative 10 divided by 2 into a, which is 1. X is equal to negative into 3 is negative 3, plus minus under root of 9, minus 4 into 1 is negative 4, and negative 4 into negative 10 is positive 40, divided by 2. So x is equal to negative 3 plus minus under root of 9 plus 40 is 49, divided by 2. And x is equal to negative 3 plus minus under root of 7 squared. The square and the square root cut out. Divided by 2. So x is equal to negative 3 plus minus 7 divided by 2. And x is equal to negative 3 plus 7 divided by 2, or negative 3 minus 7 divided by 2. X is equal to negative 3 plus 7 is 4 divided by 2, and negative 3 minus 7 is negative 10 divided by 2. So 2 and 4 cut out, we get 2. 2 and 10 cut out, we get 5. X is equal to 2 and negative 5. That's 2 of the values of x. And for y is equal to 28, x squared plus 3x is equal to 28. So x squared plus 3x minus 28 is equal to 0. Let's see if we can factorize this. AC is equal to 1 into negative 28, which is equal to negative 28. The factors are 1 into 28, 2 into 14, 2 into 14, and 4 into 7. As the product of AC is negative and B is positive, this indicates that in the pair, the factors in the pair, the greater one must be positive and the lesser one must be negative, so that their sum is positive and their product is negative. Since one of them is positive, one of them is negative. Different signs multiplied equals negative sign. So 28x minus x, 14x minus x, or 7x minus 4x. So 27x, 13x, and 3x. So x squared plus 7x minus 4x minus 28 is equal to 0. And let's just cross these out. Okay. So taking x common here, x into x plus 7. Taking negative 4 common here, negative 4 into x plus 7 is equal to 0. And now out of this whole equation, on the left side, the whole expression, taking x plus 7 common into x minus 4 is equal to 0. And now, as we know, one of them is 0. But we don't know which one is equal to 0, so we're going to say either x plus 7 is equal to 0, or x minus 4 is equal to 0. So x is equal to negative 7, and x is equal to 4. So the solution set for x is equal to 2, 4, negative 5, and negative 7. And that's the fifth case. We just talked about all 5 cases of the equations reducible to quadratic equations or to quadratic form. That's it for today's video, guys. I hope you enjoyed and understood everything today. If you have any confusions or something that you don't get or some mistake that I made, feel free to comment down in the comment section. See you later. Peace out.